I have a Ibanez CS9 chorus pedal, one of the original ones from the 1980s. It's not working, and I believe I figured out why that is, and I wanted to make a video to basically show the process that I went through and to try to fix it. Let me show you first what it's been doing, which is pretty much nothing. So if it's plugged in, when you push the foot switch, nothing happens. Look closely. So the light's not even coming on. And the same thing happens if you have the battery connected. So one of the obvious ones, for example, would be this point number 6. It says black, which corresponds to a black lead wire. So number 6 should be grounded. So the black cable is this pin right here. So this is a simple one, but I might as well start somewhere. So pin number 6 is the one, looks like this guy right here. So let's look at ground, which, so these pads right here, you actually take a screw that attaches this hole down to this screw hole here. So I know this is supposed to be grounded because it's grounded to the chassis. So starting from here, between here should be showing 0. Okay, it's quite low. Let's see. Okay, so that's the positive lead. That's where we're getting the 9 volts from the power supply. So number 6 checks out. So I started with two of the most kind of the prominent ICs on the board. The chip, the MN3207 and the MN3102. And if you notice, for example, on 3207, pin number 1 should be grounded, and on this one, pin number 3 should be ground as well. Regardless of what the different chips are doing, I know that pins 1 and 3 should be at ground voltage, at 0 volts. So I wanted to just start with easy ones and make sure that things are getting the correct voltages. You could also check to see which pins are supposed to be getting the supply voltage as well. For now, let's just check 3207, looking for pin number 1. So on this chip, pin number 1, you always start with the corner that usually has a small circle imprinted on it. That's pin number 1, and you count around till you get around to the opposite side. So that's 1, 2, 3, 4, 5, 6, 7, 8. Having the ground terminal on the rear of the input jack, which should also be at ground, and then measuring the first pin of the 3207 chip. See, that's strange. We're getting 5.5 volts when, according to the circuit diagram, the first pin of that chip should be grounded. So that's a problem. Let's also check the other chip, and that would be pin number 3, which also should be grounded. So 3 and 1 should be connected both to ground. So the pin number 1 is over here, so 1, 2, 3. Oops. And again, we're getting 5.5 volts. So already I know something's wrong, and I have a good place to start looking for the reasons why those might be at the wrong voltages. So I flipped the board over. I'm looking for the back side of those two chips. That's these two rows of 4 legs each. So that's which chip? That is 3102 is this guy, and the 3207 is this guy. This is pin 1 and then 1, 2, 3. Okay, so let's check that one compared to ground. There we go, that's that 5.5 volts we were seeing earlier. Okay, now if you just follow the trace, this should connect up to pin number 1 on the other chip, the 3207 chip. So just following this trace, okay, so this should all be at ground here. This should be grounded, and my guess would be this is pin number 1 of the 3207 chip. Okay, so let's double check the voltage there. And once again, 5.5 volts. Okay, so now let's see if we can figure out why, basically where that voltage is coming from, right? It should be at ground. For some reason that's at 5.5 volts. So what actually happens when you follow this trace, for example? So on one end it terminates at pin number 3 of the first chip there. This is pin number 1 of the other chip. Okay, so you have in one direction ground, so this should all be at ground. Let's check the voltage there. For example, this should be grounded. Alright, so that's all at that 5.5 volts still. Yeah. So all these pins here, you know, looking at the top side of the board, all of these pins, yep, should be at ground at 0 volts, and yet they're showing 5.5. So let's trace this the other way. Okay, between ground and, let's say for example, this point. So once again, should be ground. It's at 5.5. Follow the trace. Again, 5.5. 5.5. Okay. 5.5. Now let's keep going down the same trace, though, right? Oh, you get to here, and it's at ground. Okay, and you keep going. This is also grounded. So again, follow that trace from here. 0, this point, 5.5, and there shouldn't be any difference between the two. I'm assuming that means between here and here there must be a break in the trace here. I'm not sure if this is just dirt or if it's actually a break. But let me show you something else. One thing I noticed is between this pin and this pin, there's a capacitor. So let me flip this over. This capacitor right here, the negative terminal is on the bottom here and the positive would be on top. My suspicion has been that this capacitor might be the issue. It's really not possible to see. If you look on the side, let's see, you can almost see underneath, and maybe it looks like the bottom is, you know, round on the bottom, which might mean that it's expanding and basically either completely dead or basically on its way out. If the capacitor goes bad, this might start to corrode more. At least that's what I've heard other people say, is that it can point to potential problems if you're seeing excessive corrosion in certain points. So something else I've done to troubleshoot this problem is that I've soldered a lead wire to the negative terminal of the capacitor. This whole line should be at ground. For some reason this side is at 5.5 volts, this is down at true ground at 0. So what happens if I force these leads to ground? So what I did is attach a lead wire and then I attached this to ground, and let me show you what happens. As you can see, nothing's happening. Now watch this. Sounds like it's working. So what I'm going to do is switch out this capacitor and start there and see if that fixes it. I'm also going to look more closely at this trace and see if I can find where it's actually been broken, basically corroded away or broken. And I might need to form like a solder bridge to basically reconnect this trace. So first I'm going to remove the this lead wire. You can see right here that when you move the capacitor, see that lead is broken right there. So that will have to be repaired anyway. There it goes. It does seem to have some goo on the bottom. My guess is that this capacitor is not good anymore. You can see the trace that's still sticking there, but it has come off. So either I'll need to re-glue that down, although it's so small, I might just use a lead wire. So this is the old one. It says 47 microfarads, 6.3 volts. This is what I'll replace it with, 47 microfarads, 16 volts. It's the closest one that I have. So I've inserted the new capacitor. Negative terminal is this guy, or leg is this guy. Probably don't need any more solder because there's already a lot on this area, but just to be safe. Okay, that looks good. Now to figure out what to do with the other leg. You can see how there's basically no shiny material anywhere around where that solder pad used to be. So basically I'm going to use just some little super glue and try to glue that pad down. Okay, so that's going to fit down on there just like that. Now I need to take it up, put a little glue down, press it back down, and just wait. maybe I can just leave it on that leg. There it goes. It's just kind of floating up there. So I'm going to take a little super glue. Okay. Now hopefully I can get this down. Come on. Oh, there it goes. Oh, there we go. Now we will solder that leg down. I believe the glue has dried on the on the solder pad here. Hey, looks pretty good. It's kind of ugly, actually. Let's see if we can change that. Okay. That'll work fine. Now the last question is how to connect the two, so from here to here is broken, and from here to here is also a broken connection. I think the copper is just, it's all gone from about there to there. I might just bend a little piece of the leg of the capacitor that I have and go from here, cross over this, bend it around down to here, and then continue on to here, and then I'll have 1, 2, 3, 4 solder points for that wire. So it needs to attach, there we go. Attach on this end, go here, and then wrap around. So let me try to mark where I need to bend it. Let's see here. So I've wrapped a piece of wire that basically will follow that path. Okay. Nice. Hey, look at that. The leg of the capacitor is now attached to that ground area. And let me guess, there's continuity between this point and where's that first pin of the chip again? Was it this one? Yep. And this one. Okay. Well, let's clean it up and turn it on. And now for the big test, let's see. All right. So there it is. It's the final repair.